And hello, everyone. And I would like to welcome you back to the stream 3 of today Data Science Conference Europe 2020. For those who are first time with us today, this is a business application of data and AI. So far, so good. We had four excellent talks on the topics how to monetize data, what we can do. We heard a lot of interesting things regarding different tools such as AML.NET, R, and etc. Also, we are continuing in the same manner. So we are moving forward with our next distinguished speaker, and it's going to be Michal Gajda, who is going to tell to us through video about Agile data pipelines ETL for 2020. And basically, in this talk, Michael is going to present principles for Agile data pipeline development that make development faster and much more transparent. He applied it to multi-cloud AP, binding, and a few other projects. Basically, what you need to know about Michael, that he is a bioinformatist turned Haskell, and after that he turned to be tech lead. He believes that all problems of the world can be solved with patience, programming, and unconstrained use of reason. So I will not take you any more of your time, and I will let Michael to continue with his presentation. So thank you all.
Hello, today I'm talking about agile data pipelines, or how we make the methodology for data pipelines to create them faster at MicaMake Private Limited. And I hope you will find those techniques useful in your own pipelines. So let's start by reminding everybody Agile core principles. First, Agile software development cares about individuals and interactions over processes and tools. Working software delivery is more important than a comprehensive documentation and specification. Customer collaboration is better to use than lengthy contract negotiation, and responding to change over the following any plan. Why is that? This is because when you are dealing with a very complex knowledge-intensive process, you prefer to move in small steps and focus on goals that can be achieved incrementally. It gives you a much higher chance of success, and in case of failure, it makes the failure very narrow and limited. So you can try again. That's the advantage of making small steps. Now we will use these core principles in a new setting for designing data pipelines. So data pipeline, Agile data pipeline core principles is that while we like fast iterations and continuous processes, we focus first and foremost on the quality of resulting observations and number of observations at each pipeline. That's very important because that means that we focus on this thing that is actually deliverable from data pipeline, which is observations. We also focus on working pipelines and aggregations of existing data over schemas, specifications, and validation rules. Validation is an end effect of a working pipeline, not the other way around, nor is validation a prerequisite of a working pipeline. Working pipeline will make your validation work. That is important because unless you are in a strict security setting, it's much better to validate on the run while exploring the data than to figure out validation rules in advance, which is basically advanced plan that goes too many steps ahead. We do it incrementally. We add validations at each step of the pipeline. Then third, analysis feedback over expectations. So Instead of expectations that we have 90% correct records or that we will get certain results from the pipeline, we move in small steps. So at each step, we should first and foremost focus on analysis feedback, the feedback from the pipeline, to see what is actual health of the pipeline currently, what data is processed, and what is the benefit of it. This is important because that shows that we don't really look at counting records that are correct or failing. We are really looking at the holistic picture from the pipeline, the overall analysis, over the all aggregation of the results, even when pipeline is not yet ready. I will show how to do it. And finally, we focus on exploration and revealing the data over a strict process. So the first thing is how to maximize number of observations per run, right? Because we believe that number of observation is important besides the iteration speed. So we use standard formats for dumping the data at every stage of the pipeline, and thus we can examine it. But more important is that for each record, we tag records with categories and warnings, basically why we see certain things. Before we even have a fatal error, we add the warning to the record or point that there is something unusual about it. This gives us later more information about the error. We never discard the errors. No, that's not the point. We don't just dump it to the log. At all times in the pipeline, we have a set of good records and bad records with the justifications why bad records are bad. So we have watertight pipelines, right? Error dashboards. We also recommend assigning unique record ID for easy tracking, just like in cloud monitoring field. Now let's get to the details and show how it actually works. So again, quality of observations first, working pipeline second, analysis feedback as our overarching way of interacting with pipeline, and exploring data. This is a running example in Haskell. So we have a record with 3 fields that we load. So first we use elaborate load transform, not elaborate transform load. So when we load the records, we just load the strings. Then we start assigning the types, parsing it, and assigning warnings whenever something fails, right? We use standard data formats. The best way to do it is through generic parsers and pretty printers. In the case of Haskell, that's deriving a generic class instances. In case of Java, that is using something like featherweight Java. In case of Go, it's actually built in the language, so you can easily add the name of the field for each record field, and so on. That is because we want to be able to show and read everything, to be able to resume computation at any point, but at the same time, we don't want to put extra effort into it. And the best intermediate data formats can be seen from the statistics. Basically, the most tools support JSON. There are a lot of tools that also support XML and CSV. So when you want the human to immediately be able to debug your pipeline, you always provide the data, at least optionally, in JSON and CSV and XML. There is also option to use CSV with nested JSON objects when you feel like the objects are a little bit too complicated for just making CSV columns, but you still want tabular format. That's because with tabular format, you can use Excel pivot tables or auto filters in LibreOffice and any other speech app. You can automatically import it to database like SQLite, analytics database, and then query it. to find the best way to find the errors, even before you implement actual part of the pipeline. Now, what about parsing interface? So the ideal view is that we have a list of columns and we produce a record. Of course, we start with failure handling. And in Haskell, you do it by making basically a list of columns to yield maybe record, which is nothing or just record. In Java, it would be returning a record or null. And this is the first important mistake you make. Why is it so? Everybody uses null, right? Well, null, strictly speaking, means no information. So when you see the error, do you really want user to see no further information? Absolutely not. You would rather attach the entire record or the failing field to the information that is needed for debugging. So you would produce a different record that is actually a record describing an error that contains maybe some or most fields of the original record and error message. One way to start with it is to produce exception. But then just producing an exception is a little bit ugly, because we want to produce more than exception. So think about it as producing an error record. You can use an exception under the hood, but your analysis should generally take a stream of records and output stream of error records and normal records. So we have either reason why it fails or the record. And the maybe or null value is a source of many opaque errors. So really take care about that. Then even worse situation is when we just use the validation by filtering records. So we say good records are above 0 and bad records are below 0. Or something even more complicated. This way we discard a lot of records because, well, it's faster to process the remaining ones. But we don't really summarize or give the information about why they failed. And then sooner or later, if you have enough records, you will just find the records disappearing and wonder at which stage of the pipeline they disappeared and why. So this is bad approach. Instead of this, you should use an approach that is partitioning. So always, instead of filtering, partition data into good data or bad data, or data in category standard treatment and some non-standard treatment, right? And then you process them further. And then you summarize which records went into which bin. And next thing is you have a null pointer exception or header of empty. That's typical with exceptions, right? So many people just throw exception and think that's a good error message. And then find out why is it null? Why there is no information when there should be one? Of course, that's helpful. What you should do, you should enrich this information that is from certain part of the parser. So for example, when parsing a column, you find the string instead of number. You should enrich this information consecutively at different levels of your pipeline, of your program, with additional information. Where in the file it is, when you know the line number, because you parse only one input. And then if you parse multiple file paths, that whenever you open a file, you start enriching the errors with this additional information. So again, you process and you get the correct records and incorrect records. And incorrect records or error records also need to be processed, also need to be somehow treated. Usually it's just adding additional error information. Where do they come from? And that's a good start, right? Then you can do advanced debugging and aggregation of these error records and find out root causes of some errors by post-processing. But first you need to enrich them with information about where did this error come from? Always treat two types of values, good values and bad values. It's like being a father, right? You love both your good child and the bad child, and you need to give them attention, whether they are good or bad, and then the whole family will grow stronger. And the next thing, when you have this error, you want to add progressively more information. So for example, if you have a parser that goes into nested JSON object, then at each stage, when you go deeper into parsing, you may add additional information to the possible error that would be raised. So for example, failure by parsing X of the coordinate or Y of the coordinate. And that's much more information than telling just, oh, this should be float at the line number 10. It tells you, oh, coordinates are wrong, right? And which ones? And what kind of coordinates there are? Are they your home coordinates, or are they destination home coordinates? That's much easier to debug such a pipeline, right? If you want to learn more about adding information to errors and enriching your output of errors, look at the contravariant logging libraries. Some languages already have it. If not, really copy them from Haskell. Then the next stage is when you have an error, you always want to find the location and a reason, right? So it's still not really very good for large data set if you just give that. That is because you always process many records. So if you will stop at the first error for any reason, for the parsing or anything else, never stop at the first error, because that means that if single record failure is 1 in 10,000, then you parse 10 records, but for 1 million records, you will never parse it at the first run. And I heard about this again and again, that we have a nice processing pipeline that validates everything. And it has to have a human that standardizes the data before they go into the pipeline. Why? Because it doesn't handle errors properly. It just breaks for them. It doesn't tell you, oh, 10 records are failing, and these 10 records you probably should fix. So it would be at least 10 times it will be fixed before anything happens and before we see aggregated results, right? Always treat your errors like bad children. Give them attention, really. And let the good children still learn the lesson, right? So we have two pipes in the pipeline, left and right, maybe many more, but at least keep all the errors still in the pipeline. The different paths, probably, right? Error path. So for the large data sets, you always, your parsing routine would yield a pair of reasons why there were errors, possibly with that attached fragments of input to it, or entire records to it, and the list of valid records, right? Then you also want to have the generic resilient looping method. So whenever you map any function over your data, you process entire data set, right? What you want to do is that you basically map function over all the items in the data set and put them into different bins, that depending whether this analytic function gives you an error or a good value, right? And keep it in the pipeline. You want to do the same for aggregations, like summing all the records. You should sum good records and sum the records that are error records, if you can sum them. If you cannot sum them, you can at least count them, right? Why is it so? So BCPS 239 actually recommends that in principle, you should have always accurate results. But when they are not entirely accurate, when there are known errors, you should first and foremost know the impact of the errors, right? So is it like one bad record, or is the sum of the investments that cannot be attributed to any type of assets of the order of $10,000? Or is it of the order of millions of dollars? And that's a big difference, right? Because either you look at the relatively minor issue for a big company, or you look at the issue that is somewhat larger and justifies the investigation, right? Because you can fix certain errors later, but if you know that they are not significant, they are not impactful, then I would not prioritize them. Because all these data will have some kind of error. So this is old school pipeline, when you have correct data that goes from upstream downstream to the output, and there is less and less chance that it passes when it gets more and more complex, and when you change something in your pipeline. At each stage, you have different kinds of errors. Sometimes you just output them to the logs, and then you need to read the logs. And that's this bad approach. So overall, you should have this way: one correct data path and one error data path. That's watertight data pipeline. Even if it leaks from the first pipe, it goes to the second, right? Because we want to save data. And then we add the information to it and merge all this data so that we are able to aggregate all the error data together and tell what is really happening. And that really gives you wonders. So like Navy SEALs leave no man behind, data SEALs should leave no record behind, right? And this is an example. So basically, pipeline quality dashboard. We process data from different cloud APIs, and we say that here we parse 100% of URLs and 100% of parameters out of 27 calls. Very high quality, but not very much. Many records. And then for 1,400 records, we have different statistics, right? Then when you aggregate this data, you can also aggregate the record types. So first and foremost, aggregate your bad children, right? Bad records. So we have different kinds of errors. And if we aggregate number of each kind of issue, and maybe even just a warning, then we immediately see what are the most impactful issues, which are the most frequent, which should be fixed first, right? It's very easy to do when you start treating your errors like equal citizens and assign proper error records to all of them, right? Because then you just aggregate them downstream. In theory, you could just dump your error logs to Fluent and try to post-aggregate it in a different program. That's really a job of data scientists to immediately give the best possible analysis results. And the error dashboard should be a part of analysis results, because it tells you what is the impact of the issues in the pipeline. That also means that you may have like 20 different errors that impact one record each, and you will not be really bothered because you know that millions of other records are correctly processed and need no further improvement, right? So that gives you some peace of mind sometimes, because you know what is the impact of the error. You can also use the data dashboard or pipeline health dashboard to sort it by different categories, like by the size or by the quality, and you have different views. Here, of course, this health dashboard is somewhat simplified. In a real pipeline, you will have much more categories, but I would still recommend using pivot tables on these aggregations. And this is another way of looking at the pipeline. right? So we use the Sankey plot here, where we have many different records. This is counted by the record number, not by criticality. For example, we can make a different display by criticality. And we see what happens with different records. And you see immediately that most of the data is correct and well supported. There are some unsupported features, but this is not the worst problem in this pipeline. The worst problem is to locating whether there is consistent documentation, for example, for each call in the Cloud API, right? And that is important because that gives you the focus to your efforts to improve the results of your pipeline. This is example from the pipeline that I used for multi-cloud API binding generation. So I have the API documentation from different companies. It's parsed from HTML. So it's not really that clean data. It's mostly human curated. Some of it is visibly automatically generated, mostly, but not entirely, like Azure. And you still see that the most issues happen that the parameter types are inconsistently labeled, or an example request is inconsistent with the parameter description, or the uncommon path format is used that is not handled. And there are actually very few unsupported features after parsing and trying to generate it. So most of the validation actually happens at the parsing and analysis stage, and results in inconsistencies that block further code generation, because this is code generating pipeline. And it's relatively small, like 10,000 records, but it's systematically managed, so we can show it here. And this really scales to data with millions of records, like similar methodology I used in banking before. So I can really recommend this approach at scale. So this is the way that allows your ETL basically to scale very quickly, and the prototype to reach very high rates of correct data that is parsed, before you really even know what is the systematic schema of the data, or any kind of have any deeper idea of what the data looks like, right? Because you didn't make any aggregation before you parse, right? So that's very, very helpful to if you really want to treat the data that you don't know. And honestly speaking, whenever I hear that, oh, we have a schema and we know the data, that turns often to be invalid. So most of the time, you don't really know and discover your data until you process it somewhat. And that's why I recommend you that you focus on this aspect. And so again, first, quality of observation, quality of error records, error messages, working pipelines and aggregations, feedback on analysis, and explore your data, right? So use standard formats, tag records, treat your bad or errors as bad records and treat them well. Go with them down the pipeline, and never discard them. Never leave records behind, right? That gives you watertight pipelines, and make sure that your analysis is valid. And even if you have bugs, you will have much easier time to fix them and find them. And just to make sure, if you have like many million of records, assign a unique record ID to each input. Because in practice, it's much easier to work by just saying, I have error in this record, right, of the date, of the certain time that it was generated, like timestamp, and then you process them and file them in a issue and store as a unit test event. So now that I remind you of all these rules that we use successfully so far, I welcome your questions. Questions will be live. Also, a public service announcement. In March in Poland, we are organizing the international workshop on Agile and functional data pipelines. I would really like to see any of you that would like to share their experiences from industry and analysis of methodologies to make data pipelines there. Please submit papers by December 15th. The workshop web page is afdp.xyz, but you can just enter this in Google and it will find it. And please consider joining, consider submitting, consider asking any questions to me if you want to.